Hello students, in this session I am presenting the two-dimensional motion. The example is a projectile that I have already given you. Next we can go to another example of two-dimensional motion, the planetary motion. Planetary motion we are using not the Euler's method. As per your syllabus you have to use the RK method, Range-Kutta method I am using. I give here the procedure of using RK4 method. The theory I think you have already studied in your numerical analysis class. So we have for the planetary motion, see, this is the gravitational attraction between Earth and the Sun. See, gravitational force G, mass of the Sun, M, small m, mass of Earth, and R is the distance between Earth and Sun. And this is the centrifugal force. So Gmm by R square is equal to V square by R. Here you can cancel small m, so that Gm will be equal to, take the R square to the right side. So you get Gm is equal to V square R. And V, if you take a circular orbit, say V will be 2 pi R by T, because the is a velocity, or because the 2 pi R will be equal to V into T, so V will be 2 pi R by T velocity. So substituting for Vm, we get this equation number 2 will become Gm is equal to V square become 4 pi square R square, 4 pi square by T square, and this origin R cube. So this total become R square into R, 4 pi square R cube by T square. So, and by Newton's law, we need to force is equal to mass into acceleration. Gravitational attraction is minus of Gmm by R square, the attraction between Earth and the Sun. So if you substitute for Gm in this equation, we get acceleration A is equal to, here acceleration A is equal to Gm by R minus Gm by R square. When you are writing a vector form, so vector A is equal, because R is in the, they have taken the direction of the A. So actually a planet is moving in a plane, we can have only two components, let x and y. Then A, you can write it as x into I, ax into I plus ay into j is equal to minus Gm by R cube. Into this R can be written as xi plus yj. So that R is the square root of x square plus y square. And so if we have x component of the acceleration, ax is equal to minus Gm, here x by x cube, it will be x by R cube, and ax, the y component of the acceleration minus Gm into y by R cube, is xi plus yj. Therefore here ax is the this thing, and this is ay. Clear? Now we can rewrite these equations as the differential equations. For velocity you can write as dx by dt is equal to vx, and dy by dt is equal to vy, and the acceleration this ax is equal to minus gmx by r cube, and this ay is equal to minus gmy by r cube. This is vx dx by dt. I know vx by dt, the formula is given here. Now we have four differential equations, equation number 9, 10 and 12, 10, 11 and 12, and we can use the RK4 method to solve these four first order differential equations. And for solving any first order differential equations, we can use the RK4 formula. If I is a function of x, then we have yn plus 1 is equal to this initial value. This is the value at a higher step. H by 6 into k1 plus 2k2 plus 2k3 plus k4 is the RK4 formula, and this k1, k2, k3 etc. are derived using a dependence of taking the y on the function x. That the formula I have already sent in my note in detail, because now we have four first order differential equations. We will have four sets of k1, each one will be given a different name. So we have to calculate four sets of k1. They will be interdependent, and also you must have 4 initial conditions also. See, the K1, first of K1 is given as function of Tn, Yn. K2 is for Tn plus h by 2, comma Yn plus K1 into h by 2. Then K3 is equal to Tn plus h by 2 into Yn plus. See, first of K1, K2 depends on K1, K3 depends on K2, and finally K4 depends on K3 also. Here we have these four sets are only one first order differential equation. We have 4 differential equations first order. So we must have 4 sets of these constant values. You can see the Python program that I already sent to calculate these values using this. When we are using Python program, we are using certain simplification. That will not affect the calculation because we are taking in this formula for the acceleration formula. Here for equation number 4, listen, we will take R as one astronomical unit. The distance between Earth and Sun is taken one astronomical unit, so R become 1, and T will take the period of Earth, which is 1 year, so T become 1. So GM will become 4 pi square. That is simplify the equation for formula. This data you can take from any geological data that is available. So for when you use this formula and calculate the x and y coordinates, and using these x and y values, you can calculate the r values also, square root of x square plus y square. And you plot them, you will get the complete path of the planet. You will get one complete path if you take t is equal to 1. That for figure you can refer to the notes that I have sent, and also the Python program is also given in that notes. So this is the Sankhya-Gupta formula. Next session, second session we will see later.